Okay, so in this module, I'll discuss some basics of vSphere storage. We'll start off with talking a little bit about virtual disks before moving on to the different virtual disk types. I'll speak a little bit on RDM, or raw device mapping. After that, we'll finish off this module with data store. We'll introduce what our data store is and go through some process of browsing data stores, expanding storage, and a couple other things. Okay. Um, let's get started with introducing virtual disk. Okay, so a virtual disk basically is a bunch of files with your operating system installing it, your application, or any other data that you have relating to that virtual machine. So when you create your virtual machine, you could create one, or in that same process, create one virtual disk or multiple virtual disks. So basically, you could have multiple virtual disks associated with that same virtual machine. You could copy these virtual disk files, you could move them, you could backup them, and basically, like any other file, you could work with them. Okay, so a virtual disk is stored as a VMDK file. So we'll get to that in a little bit. We'll talk about the flat VMDK and the actual VMDK file. So the VMDK, or the virtual disk, is basically a SCSI drive on a SCSI controller. So VMware implements a couple different types of SCSI controller, but we'll get to that in a little bit. Let me get into my WinSCP here so we could just view the actual disk and the descriptor file before moving on. Okay, so I'll just pull up my WinSCP and log in here. Let's log into one of our hosts that we have open. Let's enter my password here. Okay, so if we were to take a look, I'm connected to our ESXi1 here. If we were to browse the directory on this host, or the directories on this host here, way down at the bottom, VMFS, if we were to go in the volumes for this, I think this is where we have our, yes, this is where we have our VM store. But we'll get to data stores in a little bit. I'll speak extensively on data stores and how we create them. But for now, this is what we would see in our data store. Okay, so I just connect over with WinSCP to this host just to show you what these files actually look like, the VMDK file and the flat file. So each one of our virtual machine would be stored in a folder structure here. So let's just open one. Okay, so these are the files related to our virtual machine. Okay, the VMX file, this would be our configuration file for the virtual machine. But we'll speak a little bit about this in a few minutes. But for now, what I wanted to show you guys is our VMDK file here, and then our flat.vmdk at the bottom. Take a look at the size here. Right, this is the actual virtual disk. If we browse our data store, we wouldn't be able to see this listed as flat.vmdk. You will just see the vmdk file. So basically, the vmdk is a descriptor file for the actual flat.vmdk file. So let's just open this. Okay, let me see if I could get this open. Edit. Yes. Okay. So when we added this here, if you notice, it's a descriptor file. Coming down here, this basically gives us some information about the actual VMDK file. So the cylinders, heads, sectors, and those sort of stuff concerning the actual VMDK file. I think somewhere in here you should see that the type of provisioning that it has. Should say thin provisioning somewhere. Or maybe not in here. Yeah. So these are some basic info on the actual VMDK disk, or the actual virtual disk, which would be our flat.vmdk. Okay. Okay, so let's continue with our virtual disk here. As I mentioned previously, the VM basically connects to an a SCSI adapter, and there are four types that VMware implement. You have the bus logic parallel, the LSI logic parallel, LSI logic SAS, and the VMware Power Virtual Controllers. Okay, we'll take a look at these once we create our virtual machines. As I mentioned too, we'll discuss data storage. We'll speak a little bit on RDM. I have a separate slide for this. But RDM basically is when we are connecting our VM directly to a LAN, or you want to give your VM basically access that directly to that LAN. So in our virtual machine creation process, we could create a RDM there and map it over to a LAN. But we'll get to that in a little bit. Next, we'll talk about the virtual disk types. I want to introduce the different types of virtual disk or provisioning methods that we have. So let me just get over to that slide. Okay, so we have three methods of provisioning our disk. We have tick provision lazy zero, we have the tick provision eager zero, and finally we have the thin provisioning. Okay, so tick provision lazy zero. When we create a tick provision disk, the capacity is taken away from your data store at that point of creation. In particular, for the tick provision lazy zero, the blocks are zeroed out on the disk at the point of the write operation and not when it's created. This is different from the tick provision eager zero, where the capacity is removed from the data store at the time of creation, and also it's zeroed out at that point. Okay. With the tick provision eager zero, it's a bit longer. It'll take some more time to create this type as compared to if you were doing thin provisioning. Okay, so both types of tick provisioning utilize the storage space on our data store as they're being created, but the eager zero would be the only one that zeroed out the space at that point of creation. Okay. Our thin provisioning, this is where the space is allocated and zeroed out at the point of the write operation and not creation. It is the fastest, as I mentioned, compared with the other two methods. We have to be careful actually with thin provisioning because it's quite easy to over provision our storage. So over provisioning is basically you're allocating more space than you actually have, or you're promising more space than you actually have on your underlying storage. So if we were to do thin provisioning, we'll need to take some extra steps to monitor our storage, do some extra monitoring on the infrastructure, to just ensure you're not running out of space there. Okay. The process to create thick provision this from thin provision this is quite easy. As we'll see later, we could always just inflate that storage space. So we could inflate that, sorry, that VMDK and convert it basically to a thick provision disk. Converting from a thick provision to a thin provision is a bit more difficult. So basically, you would convert from a thick to thin if you were to do a storage vMotion. If you were to do a storage vMotion, you would have the option there of moving back from thick to thin. Also, if you were to do a clone operation, you would get to choose the type of virtual disk there. So basically, you could clone from a thick provision VM coming downwards to a thin. The VMware converter, the vSphere converter, would allow you to do that too. We will cover this actually in our demonstration. In the advanced course, we'll cover the thick to thin provisioning, and for now, we would inflate thin disk to thick as we move on. We'll do that in our demonstration, okay? Okay, so let's continue here. Next, I'll speak on raw device mapping. So let me just pull that slide up. Okay, as I mentioned previously, a raw device mapping is where we would give our VM direct access to the underlying storage infrastructure. So you're basically mapping your VM to that LUN directly. It's more suitable for Microsoft clustering scenarios. We have a couple different modes for RDM. Okay, we have our virtual compatibility mode and we have our physical compatibility mode. So the virtual RDM, this basically acts like a virtual disk file, and it's possible to use snapshots on map volumes when we're using virtual compatibility. This is different than if you're using the physical compatibility, where we are exposing all the characteristics on the remote storage hardware. All of that would be exposed the underlying infrastructure. This would basically provide some greater flexibility for our SAN management software that's running on our storage. We'll take a look at this when we create our virtual machine, how to add RDM and map it over to a LUN. Okay? Okay, next I'll want to speak a little bit on data store. Once we finish this, then we'll get over to our console and demonstrate a couple of these things that we would have discussed. So VM files are basically stored in containers or repositories, which are called data stores. When we create our virtual machine, if we have some sort of local storage there, that by default would be formatted with VMFS, and that would be our local data store. Ideally, you would want to create some sort of shared storage data store that is mapped over to a SAN. So that way you could utilize the more advanced feature of vSphere like HA and vMotion and stuff. We'll cover that in our advanced course, creating block-based storage, adding block-based storage, sorry, to our host. But for now, let's continue with the discussion on data store. As I mentioned, the data store is formatted with a VMFS file system. So VMFS is basically a clustered aware file system provided by VMware. it provides an environment where it's safe for multiple VMs to be stored on that data store, and multiple hosts could access or be attached to this data store. Okay, um, and each virtual machine would occupy like different directories on the data store. So as I mentioned, this could be created from local or remote storage, or it could be created from a vSAN, but we'll save the discussion for vSAN for our advanced course. Okay. Um, it should be noted when our VM is actually accessing storage that is remote to the host, um, say from a iSCSI or a NAS. This is transparent to the VM. The VM wouldn't actually know that it's actually going over the network to access the storage because, as I mentioned, the host would have a SCSI controller. So these traffic would would just send the VM would just think it's running on a regular SCSI it's a regular SCSI device it's accessing. Okay, so data stores can come basically from block-based storage, and these would be formatted with a VMFS file system, or they could come from a remote NFS server or a NAS. We could create a NAS data store um, from shares that are an NFS data store from shares that are hosted on a NAS. And when we do this, okay, we are not actually using the VMFS file system. The file system on the NAS or on the NFS share, that's what we'll be using there. In vSphere 6, the NFS version 3 and 4.1, both of them are supported here. Okay, so VMware recommendation basically when we are creating or mapping over our data store is that you map one data store to one LAN. So you would want to have that one-to-one relationship there. Okay. We have different versions of our VMFS. Implemented with vSphere 6 is VMFS version 5. And version 5 supports basically up to, I think it's 256 VMFS data store per host with a maximum capacity of 64 terabyte. Okay, so that's a little bit about our data store. We'll get into the demonstration on that in a little bit. I think our last slide here is virtual volume. This is new with vSphere 6.0. It's a way of virtualizing our SAN and NAS or abstracting that into a pool of resources. So basically, the data store is no longer that unit for our storage, that final unit. We now have storage containers that will represent our virtual data store. Okay. All right, so I'll move on now and pull up my browser and connect over to our vSphere web client. Okay, so here we have our vSphere client. I'll connect over to our ESXi 5 host that we have been working on. Let me pull that up in our host and cluster view. ESXi 5. Okay, storage. This is some basic summary on our storage or adapters that are currently connected. If you notice the type here, we have SCSI. This is where we have our local data store connector currently. Okay. This is some more detail on our storage device. We have our disk here with 120 gigs. This is our our only storage device in this ESXi host for now. And this is our CD-ROM drive. For our host cache, this is located here, our host cache data store. The protocol endpoint, this is related to the virtual volume config we spoke of earlier. Okay. But basically what I wanted to show you guys is the data store settings. So let's go to the storage view. And in our storage view, recall we renamed this data store file to ESXi5 local. So let's get to local here. We have our settings tab. We'll look at the settings tab first, and then we'll move over to files. So under settings, if we had more space on this actual volume, we could increase that from here. So currently, you notice we have the drive type, which is flash. We have our file system, VMFS version 5 here. The name for this data store that we have some information on the capacity for this. Okay, we have our total capacity, provision, and our free space. If you notice here, pin provisioning is supported. IO control for storage. We'll speak about this in our advanced course. And if it supports hardware acceleration. In this case, our hosts don't. This is the capability set basically for this data store. And this is the device backend. It basically shows you the underlying infrastructure, storage infrastructure that goes with this data store. Our connectivity and multipath setting. We'll deal with this in our advanced course, connectivity and the multipath settings. So let's just skip over that for now. Okay. If you go over to the file tab here, or the file menu, this would list the current files that we have in this data store. Okay, so we are on the ESXi5 local data store, and for now we have one virtual machine stored on this server. So a folder for the VCSA virtual machine, or this was the appliance that we deployed previously. A folder is listed here. Let me just open this out. Okay, so these are the files that pertain to this virtual machine. Our next module will discuss the different file types that make up the virtual machine. Well, I just wanted to give you guys an idea now where we could find this. Okay, so we have some like our log files, and this is our VMDK. This file, we have a couple of them that's deployed when you deploy the virtual appliance. Okay. Let me just find one of the disks that we could inflate. Actually, let me move over to another data store. Okay, let me just move over to another data store really fast. Let me see what I have here. Okay, let me go over to another one and see what we have. I'm trying to see a small one that we could perform a inflate operation on. So I don't want to mess with that one. Let's just see our Fedora. Oh, we could work with this. This one is not too large. What we could do is come to our VMDK file here, and before we do that, let's just go through some of the options that we have here. Um, if we need to upload a file from our computer, we could mount or upload a ISO image or an appliance. If we want to get it into our data store, we could use that. We could refresh that there with that icon. We could create new directories in here, copy uh, files. Um, we could move files here to a new location too. And then this option would help us to rename a file. And this would be the delete option. Okay. It's pretty straightforward to work in here. If you were to right click here, okay, so if you were to right click here, we should see the inflate option, unless this was created as a thick disk. Oh, this one was created as a thick disk, so let's just find another one. Um, okay, so this VMDK file, good. So if you right click here, we actually have the option in here to convert from a thin provision disk to thick provision. We'll just hit the inflate option there, and that operation has completed, if you notice at the bottom here. Um, to move back to thick disk, as I mentioned previously, that process, sorry, to thin disk, that process is a bit different. We'll need to either do a clone operation or convert, or we would also need to do a storage vMotion operation to have our disk back as thin. Okay.